In probability, an experiment is any process with uncertain results that can be repeated. The result of any single trial of the experiment is not known ahead of time. However, the results of the experiment over many trials produce regular patterns that allow accurate predictions. So, for example, an insurance company cannot know whether a particular 16-year-old driver will have an accident over the course of a year. However, based on historical records, the company can be fairly certain that about 3 out of every 10 16-year-old male drivers will have a traffic accident during the course of a year. Therefore, of 825,000 male 16-year-old drivers, 825,000 repetitions of the experiment, the insurance company is fairly confident that about 30% or 247,500 will have an accident. This prediction helps to establish insurance rates for any particular 16-year-old male driver. We now introduce some terminology that will help in our study of probability. Before we do that, here's a caution. Probability is a measure of the likelihood of an outcome that has not yet occurred. A fair coin is one where heads and tails are equally likely. Now, before I flip the coin, we say the probability of obtaining a head is 1 out of 2. However, once I flip the coin, the probability of obtaining a head is not 1 out of 2 because the outcome, whether it is heads or tails, has already been determined. This is like a sporting event. Before the game, the probability a certain team might win may be 40%. However, once the game is over, this probability does not apply since the outcome has been determined. So next we're introducing some terminology. Okay, here we have the sample space. Now, the sample space, capital S, of a probability experiment is the collection of all possible outcomes for that experiment. Now, an event is any collection of outcomes from a probability experiment. An event consists of one or more outcomes. Now, we denote events with one outcome, sometimes called simple events as lowercase e with a subscript I. In general, events are denoted using capital letters such as capital E. Now, in this next example, we're identifying events and the sample space of a probability experiment. Now, a probability experiment consists of rolling a single 6-sided fair die. Now, a fair die is one in which each possible outcome is equally likely. So, for example, rolling a 2 is just as likely as rolling a 5. So we're going to answer the following questions. Okay, it says identify the outcomes of the probability experiment. Now, the outcomes are the possible results of the experiment. The outcomes from rolling a single fair die are the following. Well, when we have a die and it's 6-sided, that means we have, first of all, the 1, event 1. So this is a simple event, is rolling a 1. Next, we have a simple event 2, E2, is rolling a 2. And then simple event 3 is rolling a 3. Simple event 4 is rolling a 4. Another simple event 5 is rolling a 5. And the last one, we're going to say that simple event 6 is rolling a 6. So these are all the possible outcomes of the experiment. Now what we're going to do is we're going to define sample space. Okay, now recall that the sample space is a list of all possible outcomes. Okay, now the set of all possible outcomes forms the sample space, and that sample space is equal to the set 1, 2, 3, 4, 5, 6, since we have a 6-sided fair die. Therefore, there are 6 outcomes in the sample space. Next, what we want to do is we want to define the event E, which is equal to roll an even number. So the first thing we're going to do is we're going to say, okay, define the event E, and we're going to say equals, and then in quotes, roll an even number. So if the event E is equal to roll an even number, then what would this set be? Well, it would be the set of all even numbers from that sample space. Well, the even numbers from that sample space are going to be the set 2, 4, and then 6.